A robot that feels 3 grams of pressure, lighter than a paperclip, and costs less than $20,000. That touch sensitivity number sounds like a footnote. It isn't. It might be the single specification that separates Figure 03 from every humanoid robot that came before it. And I'll explain exactly why before this video ends. Humanoid robots have been almost ready for a decade. Every year brings a new demo, a new promise, a new reason to wait. But something is structurally different about where this technology sits right now. The economics are shifting. The hardware is closing the gap. And the companies betting against this transition are going to find out they waited too long. The Figure 03 robot is the third-generation humanoid from Figure AI, a company that went from a concept pitch to a BMW factory partnership in roughly 2 years. That is not a normal timeline. In the humanoid robot 2025 landscape, you have a handful of serious contenders. Tesla Optimus, Boston Dynamics Atlas, Agility Robotics Digit. Figure isn't the oldest name on that list, but with the 03, they may be making the most calculated engineering argument. At 173 centimeters and 61 kilograms, it's built to fit inside spaces designed for humans, not to impress on a stage. The Figure AI humanoid isn't designed to look intimidating. That's a deliberate choice. At 173 centimeters, it's average human height. At 61 kilograms, it's lighter than most adult males. Proportions aren't accidental. They're optimized for the environments that already exist. Factory floors, warehouse aisles, doorways. If you build a robot that can't navigate a standard door frame or reach a standard shelf, you've built something that requires the world to change around it. Figure's bet is the opposite. 44 total degrees of freedom. That number is an engineering argument, not a spec sheet boast. More DOF adds complexity, failure points, and cost. 44 says, enough mobility to do real work without over-engineering it into fragility. Some competitors are pushing past 50 DOF, which raises a fair question. Are they optimizing for deployment or for the demo reel? 8 cameras give it full situational awareness, not 6. 8 covering the angles that a smaller array leaves partially blind in tight, cluttered spaces. Every hardware decision on the Figure 03 reads like someone kept asking the same question. What does this actually need to work? And then stopped there. The body is only half the story. The Helix AI robot system running inside Figure 03 is where the real engineering ambition lives. Helix is Figure's proprietary AI, not a licensed model, not an off-the-shelf stack. It's trained specifically for physical reasoning, understanding objects in 3-dimensional space, anticipating movement, deciding how much force to apply and when. Most people hear AI robot and picture something following a fixed script. Pick this up, place it there, repeat. Helix is built to generalize. That means it can approach an unfamiliar object in an unfamiliar orientation, in a workspace it hasn't seen, and still make a reasonable decision about what to do. That is genuinely hard. It's the difference between automation and adaptability. Here's what I think most coverage gets wrong about Helix. The benchmark isn't other robots. The benchmark is a human worker on day 2 of a new job. Can this system observe, adapt, and execute without explicit reprogramming every time something changes? Figure's early deployment results suggest Helix is closer to that benchmark than anyone anticipated. Not there, closer, and that gap is narrowing faster than the competitive field expected. 16 degrees of freedom in the hands alone. When you look at the best humanoid robots ranked by Dexterity, most competitors land between 11 and 14 hand DOF. 16 is meaningfully more. And every additional degree adds mechanical complexity and potential failure points, which means Figure made a deliberate trade. They decided Dexterity was worth the cost. The question is why? And the answer connects directly back to those 3 grams. 3 grams of touch sensitivity means the hand's force sensors can register contact lighter than a standard USB cable resting on your palm. In practical terms, Figure 03 can handle objects that previous humanoid hands would crush, deform, or fumble. Fragile components, flexible packaging, irregularly shaped items that require constant micro-adjustments mid-grip. Think about what that unlocks: electronics assembly, pharmaceutical packaging, food handling. These are industries that have resisted full automation precisely because the objects are too variable, too fragile, too unpredictable for conventional robotic systems. A gripper that can feel 3 grams changes that calculation. Not for every task, for enough tasks that the economics of deployment start to look completely different. Everyone's quoting this number. Most people haven't stopped to understand why it actually matters. We've covered the body, the AI, and the hands, but the specification that will determine whether Figure 03 succeeds or stalls in the real world isn't any of those. The AI-powered humanoid is only as valuable as what surrounds it: the economics, the infrastructure, the operational reality. We're getting to that now. Under $20,000, that number deserves a moment. Every serious humanoid robot currently deployed in industrial settings costs somewhere between $70,000 and $250,000 per unit. Figure's target price for a humanoid robot under $20,000 isn't just aggressive, it's a structural argument about who gets to use this technology. At $250,000, humanoid robots are capital expenditure decisions requiring board approval. At $20,000, they start to look like equipment purchases. That's a different category of buyer, a different sales cycle, a different scale of adoption. The production goal of 12,000 units per year tells you how seriously Figure is treating this price point. That's not a pilot program number. That's a supply chain commitment. And to hit it at sub 20K, you have to achieve manufacturing scale that doesn't exist yet in this category. They know that. The target is designed to force internal discipline and to signal to customers that this is not a boutique product. I want to be direct about one thing. Getting to sub 20K at scale is extraordinarily difficult. Battery costs, precision sensor arrays, high DOF actuators. These components don't get cheap quickly. Early units will almost certainly cost more. The $20,000 figure is where they're going, not necessarily where they are. That distinction matters if you're evaluating this as a near-term purchasing decision. 5 hours of runtime, 4.3 kilometers per hour walking speed, 20 kilograms of payload. These numbers need to be measured against humanoid robot real-world use, not controlled demos. 5 hours is a real constraint against a standard 8-hour shift. That means either a mid-shift swap, which requires redundant units, or a recharge window built deliberately into the workflow. Figure's 2 kilowatt wireless charging helps. You can design a workstation where the robot charges passively during natural downtime. But that requires workflow redesign, not just hardware installation. Companies adopting Figure 03 are not buying a robot, they are redesigning a process. 20 kilograms of payload handles the majority of repetitive manual tasks: picking, placing, sorting, assembling. It does not handle heavy lift exceptions that human workers currently manage. That's not a failure, it's a scope decision. A robot that tries to do everything usually does nothing well. What I find most significant about Figure 03's deployment trajectory is the BMW partnership as a proof of concept framework. BMW isn't a startup taking bets on unproven technology. When a manufacturer at that scale commits to a humanoid pilot, it validates the deployment model, not just the hardware. That signal is worth more than any spec sheet. Here's the conversation most tech coverage avoids. What does a 12,000 unit annual run of humanoid robots actually mean for the humanoid robot workforce dynamic? The optimistic framing is augmentation. Figure 03 goes into environments that are genuinely dangerous, repetitive, or understaffed. It handles tasks companies struggle to fill. It frees people to move into roles requiring judgment. That's a plausible scenario, and there are real industries where it maps accurately. The more complicated framing is displacement at scale. At $20,000 per unit, you're looking at a capital cost that pays back in roughly 1 year when replacing a full-time position. That math will not be ignored by CFOs running labor-intensive operations. My read: Figure 03 and machines like it will create the same disruption that spreadsheet software created for accounting departments in the 1980s. Some roles disappear, new roles emerge. The net effect takes a decade to fully understand. The companies and workers who adapt earliest absorb the benefit. The ones who treat this as a distant problem will find it arrived faster than expected. That's not alarmism. That's pattern recognition from every previous wave of industrial automation. Humanoid robot factory deployment is expanding faster than the safety and reliability data supporting it. That's a sentence the industry doesn't like saying out loud, but it's accurate. Figure 03 is impressive engineering. It is not a finished product in the way a laptop or an electric vehicle is a finished product. It's a platform under active development, being tested in live environments. Helix AI's generalization capability is promising, and it is also the least predictable component of the system. An AI that adapts to unfamiliar situations can also adapt in unfamiliar ways. Edge cases in complex manufacturing environments are not fully mapped. The wireless charging and runtime dependency require new thinking in facility design. The 3-gram touch sensitivity is extraordinary. It's also a sensor system that needs regular calibration, maintenance cycles, and replacement schedules that don't fully exist yet as an industry practice. I'm not saying Figure 03 isn't ready for deployment. I'm saying the companies deploying it need to approach it as a collaboration with an emerging technology, not a turnkey solution. The difference between those two postures will define which deployments succeed and which ones become cautionary case studies. There will be both. So, back to those 3 grams. Figure robot specs and price get most of the headline attention, understandably. But touch sensitivity at 3 grams is the specification that changes the category. Every humanoid robot before this has been limited to structured, predictable tasks. Because without fine tactile feedback, you can't safely handle variable objects at speed. 3 grams opens the door to unstructured environments. That's not an incremental improvement. That is the unlock that makes the economics work. If this kind of grounded analysis is what you're after, this channel covers the technology that actually matters. Figure 03 isn't the robot that replaces everything. It's the robot that proves the model works, at a price and capability that makes the next iteration inevitable. The real question isn't whether humanoid robots enter industry at scale. They will. The question is how fast the institutions around them, companies, regulators, workers, adapt to a machine that can actually feel what it's handling. The answer to that question will arrive sooner than most of those institutions expect. If someone in your life still thinks humanoid robots are a decade away, this is the video to send them.